see this, for every n cross n real matrix A, actually there exists, should be there since it is a note. Okay, there exists a unique monic polynomial of least degree that annihilates A. Okay, so this is guaranteed. It is guaranteed that whenever you talk about any matrix A, now in our syllabus we are talking about only real matrices. So whenever you talk about a real matrix A of order n, then it is going to have a minimal polynomial, that is guaranteed. Actually this is the theorem, but proof we are going to discuss later on. Okay, then minimal polynomial is always non-zero. Okay, so that is the next thing that you should note, that your minimal polynomial is always going to be non-zero. Okay, degree of the minimal polynomial of a matrix of order n is at most n, just now I have told you. And minimal polynomial is always unique, means it is not like that your minimal polynomial is going to be you will get two different minimal polynomials. This will never happen. So everyone in the class is going to get only one minimal polynomial. Okay, so this is the meaning. Yeah, so minimal polynomial is unique. Now few remarks that will be useful for us to find the minimal polynomial. So minimal polynomial of a matrix always divides every polynomial which annihilates A. So this is very interesting. I mean, if you are having some matrix A, suppose, and we know some polynomial G that is annihilating A, then it is guaranteed that our minimal polynomial m of x is going to divide what? G of x. So that is what this result is saying, that minimal polynomial of a matrix divides every polynomial which annihilates A. I hope you remember the concept of divisibility. Okay, and hence minimal polynomial of A divides the characteristic polynomial. I mean, since minimal polynomial divides every polynomial which annihilates A, and we already know that characteristic polynomial annihilates A, therefore minimal polynomial is going to divide the characteristic polynomial, and this is very important in order to guess what should be our minimal polynomial. Okay, so how can we use this remark 1 in order to guess our characteristic polynomial? So for that purpose we are supposed to express our characteristic polynomial in terms of linear factors. So suppose my minimal polynomial is x minus 1, x minus 2 and x minus 3. Okay, now since this is a characteristic polynomial, let me say of matrix A, which is of order 3, so it is guaranteed that f of A is going to be equal to 0, no doubt about this. Now the question is whether this f is the minimal polynomial or not. Okay, that is a question. It will be a minimal polynomial if there is no polynomial having degree less than 2 and which is annihilating A, right? So see how this remark 1 is useful. Now by remark 1, minimal polynomial divides the characteristic polynomial. So what are the possibilities of minimal polynomial? It can be either x minus 1, it can be x minus 2, it can be x minus 3, or okay, I am saying or it can be also x minus 1 multiplied by x minus 2. Okay, or it can be also x minus 1 multiplied by x minus 3, or it can be also x minus 2 multiplied by x minus 3, or what is the last one? It can be itself the characteristic polynomial itself. So these are the possibilities: 1, 2, 3, 4, 5, 6, 7. Still a lengthy job. Okay, so it is very lengthy job. So we require some more extra things in order to reduce these possibilities. So this checking these 7 possibilities is very lengthy job. Okay, so we should have some other result which will cancel few of these possibilities, so that it will be easier for us to calculate minimal polynomial, and definitely you are having that result. I will tell you what it is. Okay, I hope you got it, why I have these 7 possibilities, because since minimal polynomial is dividing the characteristic polynomial, just pick okay the factors of your characteristic polynomial and consider all the cases. Okay, now see what is this second remark saying: alpha is the root of minimal polynomial of A if and only if alpha is a characteristic root of A. Characteristic root in the sense eigenvalue. Eigenvalue in the sense root of the characteristic polynomial. So in other words, you can say whatever the roots of minimal polynomial are there, same will be the roots of characteristic polynomial. Is that okay? Very interesting remark, the second one. it is very strong. So whatever roots of characteristic polynomial are there, same should be the roots of what? Minimal polynomial. So now can you guess the minimal polynomial for this characteristic polynomial? What should be our minimal polynomial? See, what are the roots of this characteristic polynomial? In this case they are 1, 2 and 3. So out of these 7 possibilities, which possibility has 1, 2, 3 roots? It is only one, and which is that? This is it, isn't it? So therefore this should be only our minimal polynomial, because if you consider the other possibilities, this has only 3 root, this has only 2 as a root, this has only 1 as a root, this has 1 and 2 roots, this has 1 and 3 as a root, and this has 2 and 3 as a root. But what should happen? Since the roots of minimal polynomial and characteristic polynomial are same, so 1, 2, 3 should be the roots of minimal polynomial as well. So therefore this is the only case. So we have discovered a very important theorem. If your characteristic polynomial has distinct roots, all the roots are distinct, then your minimal polynomial will be exactly equal to what? The characteristic polynomial, because there are no other choices left out for what? The minimal polynomial. Okay, that exactly, I think, have I given that note over here? No. Okay, but I will mention it here if you want. Then minimal polynomial, very important remark. Now let us go for the next one. Similar matrices have the same minimal polynomial. Important thing, we have already seen the concept of similar matrices. Two matrices A and B are said to be similar if we are able to find a non-singular matrix P such that A should be written as P inverse BP. Then we say that this A and B are similar matrices. So similar matrices have same minimal polynomial. Now next is very important. If d1, d2 up to dk are distinct diagonal entries of n cross n diagonal matrix A, then the minimal polynomial is x minus di, where I is varying from 1 to k. So in order to explain this fourth node, I should give few examples, then it will be clear. Okay, so suppose let us say this matrix you are having 1 0 0 0 1 0 and 0 0 2. Now it is a diagonal matrix, but this fourth remark is saying that whenever you are having a diagonal matrix, after looking towards it, you can tell what is a minimal polynomial. Simply see the roots of the not roots exactly, simply see the diagonal entries of the matrix. What are the diagonal entries? 1 1 and 2. It means 1 1 and 2 are the eigenvalues, I mean they are the roots of the characteristic polynomial. Okay, because your characteristic polynomial will be x minus 1, x minus 2 and x minus 1 only. It is easy to check. So in such case your minimal polynomial is x minus 1 multiplied by x minus 2. Okay, that is what it is said here. Product I is varying from 1 to k x minus di. So you have to just think of the distinct diagonal entries. Okay, and with the help of that distinct diagonal entries, you can easily tell your minimal polynomial. If I take another example, let me take some big matrix. Suppose I am having a 5 by 5 matrix 1 0 0, rest of the entries are 0. I will write it like this. Diagonally, suppose I am having a 5 by 5 matrix 1 2 1, let me say 2 and 3. So can you guess the minimal polynomial? The minimal polynomial is going to be x minus 1, x minus 2 and x minus 3. That's all. Just pick up the distinct diagonal entries. I mean there are only 3 distinct diagonal entries, that are 1 2 3. Okay, so therefore this is going to be your minimal polynomial. But this is true in the case of what? If you are having a diagonal matrix. Now there may be some questions, or there may be I will say questions asked, that you have to tell what will be the possibilities of minimal polynomial. Suppose your characteristic polynomial you are knowing. In order to find the minimal polynomial, characteristic polynomial is very important. Without characteristic polynomial, you will not be able to find the minimal polynomial. Suppose my characteristic polynomial is x minus 1 cube, let me say, and x minus 2 square. So you can see that it is a characteristic polynomial of a matrix A having order 5, because how many roots are there? 5 roots, 1 1 1 and 2 2. So the question is, what will be the possibilities of minimal polynomial? So the possibilities are, first one will be x minus 1 multiplied by x minus 2. Okay, next possibility is going to be x minus 1 square. I will fix x minus 2 first of all. So x minus 1 square x minus 2. Next one, x minus 1 cube x minus 2. Okay, आता अशा पॉसिबिलिटीज नसणार बघा, x-1 नुसतं आणि नुसतं x-2 ही पॉसिबिलिटी नसणारच. कारण काय आहे, कारण की मिनिमल पॉलिनॉमियल आणि कॅरेक्टरिस्टिक पॉलिनॉमियलचे रूट सेम पाहिजे. सो दॅट टेक केअर शुड बी टेकन. So therefore simply the factors of x-1 and only the factors of x-2, that cases will be ruled out. Okay, so whenever you talk about minimal polynomial, it should have a factor, at least one factor of x-1 and at least one factor having what, x-2. So now what are the next possibilities? Now simply fixing x-1 x-2 square, over here x-1 square x-2 square, and over here x-1 cube x-2 square. So these are all the possibilities of the minimal polynomial. Now the thing is how to find the minimal polynomial. So in order to find it, always think of the least degree. So which is the least degree polynomial among this? It is the least degree polynomial. So you simply check whether a minus I outside the bracket a minus I multiplied by a minus 2i is equal to 0 or not. You simply check this. If this comes out to be 0, then you can surely say that this is going to be your minimal polynomial. But if it comes out to be 0, मग त्यानंतरचा ह्याची डिग्री 2 आहे ना, मग आता डिग्री 3 असणारे बघायचे. डिग्री 3 असणारा मला 2-3 दिसत आहेत इथे. हा एक डिग्री 3चा दिसतोय, येस, हा एक डिग्री 3चा दिसतोय, हा एक डिग्री 3चा दिसतोय. मग याच्यासाठी तुम्ही चेक करा. त्याच्यासाठी काय चेक करणार, वेदर a मायनस आय होल स्क्वेअर a मायनस 2y 0 आहे की नाही ते चेक करायचं, क्वेश्चन मार्क. किंवा हे चेक करा, a मायनस आय मल्टिप्लाइड बाय a मायनस 2y स्क्वेअर इज इक्वल टू 0. बघा, जर एकाचं नॉन झिरो येत असेल, असं होणार नाही की दोघांचं 0 येईल, कारण की मिनिमल पॉलिनॉमियल युनिक असतो. मग एक तर हा 0 येईल किंवा हा 0 येईल किंवा दोन्ही नॉन झिरो येतील. ओके, जर दोन्हीपैकी एक 0 आला तर then that will be our minimal polynomial. If both comes out to be non-zero, then you go for having degree 4 now. ओके, तर 4 डिग्रीचे हा एक दिसतोय आणि हा एक दिसतोय. याच्यासाठी चेक करा. याच्यासाठी काय चेक करणार, a मायनस आय, याच्यासाठी मी म्हणतोय a मायनस आय क्यूब मल्टिप्लाइड बाय a मायनस 2i 0 येते की नाही. हे जर 0 आलं तर हा मिनिमल पॉलिनॉमियल होणार. हा जर नॉन झिरो आला त्याच्यासाठी चेक करा. याच्यासाठी काय चेक करणार, हा a मायनस आय होल स्क्वेअर मल्टिप्लाइड बाय a मायनस 2i स्क्वेअर. ओके, a मायनस 2i स्क्वेअर 0 आहे की नाही. हा 0 आला तो मिनिमल पॉलिनॉमियल येईल. पण जर तो पण नॉन झिरो आला, याचा अर्थ मिनिमल पॉलिनॉमियल काय असला पाहिजे, हाच. दॅट इज एक्झॅक्टली युअर कॅरेक्टरिस्टिक पॉलिनॉमियल. सो दिस इज द मेथड to find what, the minimal polynomial. Now we will go for few examples of minimal polynomial so that you will get the idea how to find minimal polynomial.